Hey everybody! Today we are going to be solving the pH of a strong acid. And for the purposes of this video, we are going to be assuming that the acid fully dissociates. Now, nothing's going to interfere. We chuck that acid into water and it's going to fully dissociate and give us the pH that we're looking for. So let's get started. The equation that we're going to be using is pH equals the negative log of H3O+, the concentration of our hydronium ion. And that's what water becomes once we donate an H+ to it. Our first example that we're going to do is going to be a concentration of HCl hydrochloric acid equal to 0.006 moles per liter. And you need to ask yourself, each little hydrochloric acid, how many hydrogens is it going to donate? And we can actually write out a dissociation equation here and get hydrochloric acid plus our water, a liquid, and it's going to equal H3O plus aqueous plus chloride anion, and that's also aqueous. And from the balanced chemical equation, we can see that it's a 1:1:1:1 ratio, which I know my clever little cupcakes already identified that. So we can write that the concentration of HCl to the concentration of H3O plus is 1:1. And that just means that the concentration of H3O plus is going to be the same as the concentration of HCl, so it's equal to 0.006. Our pH is equal to the negative log of 0.006. Our pH will equal 2.22. And if you don't need to write that dissociation equation, and you can kind of look at the HCl and be like, okay, I know this is going to be a 1:1 ratio, this style of question becomes quite fast. Let's scroll down. We're going to do a second example here. For our example number 2, and we'll be assuming full dissociation of this one as well, we're going to start off with a concentration of sulfuric acid that is equal to 3.6 times 10 to the negative 6. Sulfuric acid's different than hydrochloric acid because it can donate 2 H+. If we were to write out this simplified dissociation equation, we'd end up with H2SO4 aqueous plus 2 waters is going to produce 2 H3O plus our sulfate. This time, instead of our high sulfuric acid being a 1:1 ratio with our hydronium, this time for every 1 sulfuric acid we have, we're going to get 2 hydronium. So we take this 3.6 times 10 to the negative 6, and we're going to multiply it by 2 because we're producing 2 H3O plus, and this is going to equal 7.2 times 10 to the negative 6 moles per liter H3O plus. We're going to fill this into our pH equation. pH is equal to the negative log of 7.2 times 10 to the negative 6, and this is going to equal a pH of 5.14. And we get it. And most times if you're doing high school chemistry, this is exactly how you're going to solve these pHs of strong acids. We're assuming full dissociation. There's ways to do it when it doesn't fully dissociate, but we can tackle those another time. So hopefully this helps out, and now you can solve the pH of strong acids. Thank you very much, and hopefully I'll see you next time.